Hi, welcome back to our channel and back to the tutorial for deep learning. Today I'm going to see the implementation for digit recognition using the CNN3. So as of we know already discussed about CNN. So CNN means what? It's one of the extension or extended version of ANN and where consists of convolution layer followed by pooling layer at last fully connected layer also. So lot of benefits available when you go for CNN. So just the execution of digit recognition. Like if you give 2, it will predict the 2. If you give 5, it will predict and say 5 only. So this is a one. This is a very useful one. This method 3. That means I already explained twice. And this is another method where we are going to import the necessary packages in Google Colab only. That is Pandas, NumPy, Seaborn and TensorFlow and so on, Matplot. Then we got to load the data set. So before execute this implementation, he had to download the data set that is called train.csv and test.csv. You have download and keep in a Google Drive. Then you can give the connectivity that is pd.read.csv followed by the test also. Test is equal to pd.read.csv, read_csv followed by test.csv. After only you can continue the coding here, then print, then x you can assign the x value, y value, test value. Then you can give can give the tsne coding, and we can use a plot plt.figure out where we give the size of 14,12, and we can give colors bar. Once give and execute, we show like this for representation of digital recognition only. Then we can continue the coding called where we can get the help of sklearn.model, and we can give train validation and everything by default. Then we can print the values for x train, y train, x validation and y validation. It prints the result like this. So if your internet speed is good, you can execute the coding very fast and implementation also very easy for you. Then we again give you the numpy, reshape the values and continue the print x train, y train on the image with the image height. You are going to adjust everything based on your requirements. Then we can give again training the data, and we can give the check the data frame with the help of x underscore train underscore re of 0, and it will display the information like this. So we are taken the model from the basic of MNSIT only, and it show the information like this number. It show the value. So by default it show the plt.xticks followed by plt.yticks up and so on. The clarity like that only. It display the information. Some random images from the digital recognition 5, 7, 2, 3, 6, 5 like this 4. With the help of CNN we can predict everything with accuracy, and then you can give the train with the channels and validation channels followed by the channels value and normalization value, and we can train the model, very important, where I can use the code called tf dot keras dot model dot sequential. Then we can give the input shape as image underscore width underscore height and image channels and so on. Then we can apply the filters, states, activation as of you already discussed in the CNN basic concepts. At last we can go for the summary, that is model dot summary, to give the result like this, where we are applied the CNN. We are applying the CNN convolution layer, max pooling layer. Max pooling layer generally used for reduce the dimensionality of the data, and followed by the fully connected layer and so on to predict the output and everything. Then we can train the model where you can give the code called tf dot keras dot utils dot plot underscore model, and bracket you can give model comma show shapes equal true and show underscore layer is equal to name true. That is display the graphical representation of the CNN architecture. Very useful and helpful for you understanding. Then as I already told you, you can go for autumn optimizers for get the accuracy, that is where you can get optimizer accuracy values, and we can go for log dot fit also. The step where you will take more timing. Don't worry, once you give the steps properly, implemented properly, it takes some time and print the value. Then you go for approach number and accuracy. So once you go for CNN accuracy, this method, you can see the graphic accuracy where you have labels for training set, another label for validation set where showing the accuracy and validation accuracy like this, and it show in the matplotlib library also. So it's showing around like this, showing accuracy and more than 0.98 and so on. Then you can go capture and follow the digit recognition underscore CNN.h5 model, Then go for prediction one part method, where you can give the line coding like this, where you predict the information of like number. The number display is low pixel quality. It may vary based on the data set. Don't worry. So you can try like this. So this way, how we can recognize the digital recognition, the digital, yeah, digital image, sorry, digit numbers recognized using the CNN. So you can easily, with the help of CNN, what you can do, we can import the packages, then you can build the model. At last, and test and validation, at last you can go for the final output. So once you give the proper data set and everything, the final output may vary, where it display the so many numbers like 2, 3, 5, 7, and so on and so on. I hope that you understand the video. If you like the video, please subscribe and share with your friends. Thank you for watching the video. Thank you.